Hi everyone. Today let's look at a classic problem, two-sum. Opening. The problem gives us an array of integers and a target value. We need to find two numbers in the array that add up to the target and return their indices. There is always exactly one solution, and we may not use the same element twice. Naive approach. Our first idea is to check every pair. For each number, scan all the numbers that come after it and see whether the two add up to the target. This works, but it compares many pairs. For an array of length n, we look at roughly n squared pairs in the worst case, which becomes slow for large inputs. Core idea. The key insight is to flip the question. Instead of asking which number pairs with the current one, we ask for each number, what value would complete the target? That missing value is called the complement, and it is simply the target minus the current number. If we have already seen the complement, we are done. So as we walk through the array, we keep a hash map that remembers each number we have passed and the index where it's sat. Looking something up in a hash map is essentially instant, so the whole scan runs in one pass. Key details. One subtle point is the order of operations within each step. We check the hash map before storing the current number. This matters when the array has duplicate values, like two 3s that should add up to 6. The first 3 finds nothing in the map and gets stored. The second 3 then computes its complement, also 3, and finds the first one already sitting in the map. Because we never store the current number before checking, we never accidentally pair an element with itself. Walkthrough. Let's trace the first example. The array is 2, 7, 11, 15, and the target is 9. We begin by creating an empty hash map to remember each number and its index as we scan. We pick up the first element at index 0, whose value is 2. The map is still empty at this point. We ask what value, together with 2, would reach 9. The complement is 9 minus 2, which is 7. We look for 7 in the map, but the map is empty, so there is no match. No pair ends here. So we store the current number. We record 2 with its index 0 in the map, so that a later element can find it as a complement. We move to the next element at index 1, whose value is 7. The map now holds one entry, the number 2. We again ask what value completes the target. The complement is 9 minus 7, which is 2. We look for 2 in the map, and this time it is there, sitting at index 0. The two numbers, 2 and 7, add up to 9, so a pair is confirmed. We return the stored index 0, together with the current index 1. The answer is the pair of indices 0 and 1. Complexity. The running time is linear, proportional to the length of the array, because we scan the array once, and each hash map lookup is constant time. The space is also linear in the worst case, since the map may hold nearly every number before the pair is found. Summary. The two-sum problem is the classic example of trading a bit of memory for a lot of time. A hash map turns a quadratic double loop into a single linear pass. The two ideas to remember are the complement, the target minus the current number, and the discipline of checking the map before storing, which keeps duplicate values correct. Thanks for watching and see you next time.